Understanding the common modes of radioactive decay. To answer this kind of question, I think the best approach is to kind of fill out the information that you know, and then you can work out the information you don't know using what you know about radioactive decay modes. Okay, so for instance, the nuclide in the column on the left is going to be what you start with, and then the daughter nuclide will be what you have after the decay process has taken place. So depending on what the known and unknown is, you can kind of work out. So we don't know what the decay mode is right now, but we know that it's going to decay and form the daughter nuclide, which is going to be 176 and then 72 hafnium. Because remember, the atomic number tells us um, what the identity of this atom is. So I'm going to have some kind of unknown particle or something that is being spat out with an unknown A and Z and an unknown identity, and that is what I'm going to try and work out. Just like a chemical equation, right, the sides of a nuclear equation have to be equal. So my mass number on the left side, 180, has to be the same as the sum of the mass numbers on the right-hand side. So 176 plus something is 180. So that something is going to be 4. Okay. Um, any guesses what it is yet? So on the bottom, okay, so the proton number, the atomic number is 74 on the left, and on the right it is something plus 72. So something plus 72 equals 74. So that something must be 2. Okay. So if you're not sure, go to the periodic table and look up what has a atomic number of 2, and you're going to find that is helium. So the emission of a 4-2 helium nucleus should be going ding, ding, ding. I know what that is. That is what we have defined as alpha decay or alpha emission. So it is emitting an alpha particle. So I don't know if I'm able to select here. Oh, I can. Alpha emission. There we go. All right, so moving on, what's next then? So we've got the parent nuclide, 9943 technetium, and then it's undergoing beta emission. Okay, I'm going to put that in the bank for a second. It's emitting a beta particle, and then it's got some unknown daughter nuclide it's going to result in. Okay, so what is a beta particle? A beta particle is the emission of an electron. So electron has 0 mass and a -1 charge. And then the product of that decay is going to be our unknown daughter nuclide. So I'm just going to put, I don't know, question mark for A, question mark for Z, question mark for X, the element identity. Okay, so again, both sides of the nuclear equation have to be equal. So if on the left the mass number is 99, on the right 0 plus question mark has to equal 99. So that's going to be 99. Okay, so far so good. On the bottom, the atomic number, proton number 43 on the left-hand side has to equal -1 plus question mark. So that unknown must be 44, right? 44 minus 1 is 43. So now from our proton number, our atomic number, that will always give us the number of protons in the nucleus, which always gives us our element identity, because that is literally how we define an element, by the atomic number Z, the number of protons in the nucleus. If the number of protons has changed, then the element identity has changed. So blah, 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 look in your periodic table, Z of 44 is ruthenium, which has the symbol Ru. So then we have to do the last one, which we've been told is positron emission. This time we don't know the parent nuclide, so I'm just going to make that question. So we're going to be emitting a positron, and a positron is a positively charged particle, which is basically the opposite to an electron, an anti-electron, if you like, because the charge is opposite. And we've been told our daughter nuclide is neon 22, so 22, 10, neon. Okay. So we're going to have to work out what our mystery parent nuclide is. Okay. So 22 plus 0 will give us a mass number, which is going to be just 22. On the bottom, 10 plus 1 is 11. So our atomic number must be 11. Therefore, look in your periodic table, your element identity is going to be sodium. So that is Na. And that's all you have to do there.